Hi class, in this video we are going to represent a logarithmic function through its equation, table of values, and graph. We are also going to find its domain, range, intercepts, zeros, and asymptote. Let's have our first example representing the logarithmic function with base greater than 1. We have y is equal to logarithm of x base 2. So first, let's construct the table of values of the ordered pairs for the given function. So same process lang po ito na ginagawa natin when we try to evaluate function. We just input the values of our x to our equation. So for this one, let's have 1 over 16. So we have y is equal to the logarithm of 1 over 16 base 2. And 1 over 16 can be expressed as 2 raised to negative 4. So we have here the logarithm of 2 raised to negative 4 base 2. And using the property of logarithm, we will have negative 4 as our y. Next, we have y is equal to the logarithm of 1 over 8 base 2. For 1 over 8, we can express this one with base 2 as and an exponent as negative 3. So we have the logarithm of 2 raised to negative 3 base 2. So using again the property of logarithmic logarithm, we will have negative 3. Next, y is equal to the logarithm of 1/4 base 2. And 1/4 can be written as 2 raised to negative 2. So we have logarithm of 2 raised to negative 2 base 2. So we have y is equal to negative 2. Next, we have y is equal to the logarithm of 1/2 base 2. And 1/2 can be written as 2 raised to negative 1. So we have logarithm of 2 raised to negative 1 base 2. They have the same basis, so we have negative 1 for our y. Let's continue. We cannot evaluate or input the value of x is equal to 0 because it will violate our definition for logarithmic function where your x should be greater than 0. So let's proceed with 1, 2, 4, and 8. So for y is equal to the logarithm of 1 base 2. So using the properties of logarithm, we will have 0 as our answer. Next, y is equal to the logarithm of 2 base 2. Using the properties of logarithm, logarithm of 2 base 2 is equal to positive 1. Next, y is equal to the logarithm of 4 base 2, and logarithm of 4 can be written as 2 raised to 2. So we will have logarithm of 2 raised to 2 base 2. So we will have an answer or y as equal to positive 2. Next, last, we have y is equal to the logarithm of 8 base 2, and logarithm of 8 or 8 can be written as 2 raised to 3. So you will have logarithm of 2 raised to 3 base 2. Using the properties of logarithm, we will have positive 3 as the value of our y. So when we plot the points found in this table and connect them using a smooth curve, we will have the graph of y is equal to logarithm of x base 2. So, ayan po, no? When you plot the points from our table of values and draw a smooth line or smooth curve from the points, connecting them, you will have the graph of y is equal to logarithm of x base 2. Now, let's find the domain, range, intercepts, zeros, and asymptote of this graph. So first, let's identify the domain. So again, the domain are the set of possible values of x that we could substitute to our function to make it define. So for this example, just by looking at our graph, you can see that nandun siya banda sa right side ng ating x-axis. And it implies that most likely our domain is the set of all real numbers. Right? However, meron po siyang boundary. Particularly, meron siya kasing as your x decreases, as you can see, the behavior of your y values, ayan, they are approaching your y-axis. And this y-axis is the horizontal or vertical asymptote. Vertical asymptote of our graph, wherein we have x is equal to 0 or our x-axis. So, from here, we can conclude that the domain of our graph is the set of real numbers such that x is greater than 0. And with that also, we have already identified our vertical asymptote. So for our range, let's look at the values of our y. So what are the possible values of our y when we input the values of our x? So upon checking our graph, you can see that meron tayong positive at meron tayong negative, and all set of real numbers are included as part of your range. So therefore, our range for this one, for this graph, is the set of all real numbers. And with that also, because the range of our graph is the set of all real numbers, so therefore we can also conclude that we don't have a horizontal asymptote. Next, let's have the intercept of our graph. So upon checking, obviously, we can see that at point 1, 0, our graph intersect our x-axis. So therefore, we can conclude that we have an x-intercept which is equal to 1, or in points that is 1, 0, and also, it implies that we have a 0 which is equal to 1. And upon checking our table or our graph, we can see that we don't have a y-intercept. Kasi nga po, no, kung titingnan mo po yung domain natin, we have a vertical asymptote, which is x is equal to 0, and that is also our y-axis. So definitely, we will not have y-intercept for this graph. Okay, so that concludes na. We have already found the domain, range, intercepts, and asymptote, as well as the 0 of our graph or example number 1. Next, let's have our example number 2. Sketch the graph of y is equal to logarithm of x base 1/2. This is a logarithmic function with base between 0 and 1. So first, let's construct the table of values of the ordered pairs for the given function. So same process lang po ang gagawin natin to evaluate our function. We will just substitute the values of our x in our equation or function. So first, we have the logarithm of 1 over 16 base 1/2, and 1 over 16, if we want to express it with an exponent with base 1/2, so we will have an exponent which is equal to 4 or 4. So therefore, we will have logarithm of 1/2 raised to 4 base 1/2. So therefore, our y is equal to 4. Next, we have y is equal to the logarithm of 1 over 8 base 1/2. Again, 1 over 8, express natin siya with base 1/2. So we will have an exponent which is 3. So therefore, we can write this one as the logarithm of 1/2 raised to 3 base 1/2, which is equal to positive 3. Next, we have the logarithm of 1 over 4 base 1/2. So 1 over 4 can be expressed or can be written as 1/2 raised to 2. So that is logarithm of 1/2 raised to 2 base 1/2, which is equal to positive 2. Next, we have y is equal to the logarithm of 1/2 base 1/2. So using the property, we could conclude that this is equal to 1. Ayan. Then, let's keep x is equal to 0. Let's have y is equal to the logarithm of 1 base 1/2. So using the properties of logarithm, we can conclude that this is equal to 0. Ayan, 0. Next, we have the logarithm of 2 base 1/2. So our goal is to express this 2 into an exponent wherein the base is 1/2. So what we're going to do is to raise 1/2 by negative 1. So we can rewrite this one as the logarithm of 1/2 raised to negative 1 base 1/2. So therefore, y is equal to negative 1. Next, we have y is equal to the logarithm of 4 base 1/2. And 4, if we rewrite it as 1/2 base, we will raise it by negative 2. So we have logarithm of 1/2 raised to negative 2 base 1/2. So we have y is equal to negative 2. And last one, we have logarithm of 8 base 1/2. Again, 8, pag nire-write natin siya with base 1/2, we will raise 1/2 by negative 3. So, equal pa rin naman po yung 1/2 raised by negative 3 to 8. So, we can rewrite this one as the logarithm of 1/2 raised to negative 3 base 1/2. So, our answer is negative 3. So, now we have completed or constructed our table of values. Now, let's plot this point and find the graph of our example number 2. So, when we plot the points, ito po yung magiging itsura ng ating mga points from our table of values. And when we connect them to each other using a smooth curve, ito naman po yung magiging itsura ng kanyang graph. This is the graph of y is equal to the logarithm of x base 1/2, where your base is between 0 and 1. So, in general po, we can conclude that the graph of logarithmic function depends on the value of our base. So, if our base is greater than 1, ganito daw po ang magiging itsura niyan. So, as our x increases or approach positive infinity, our y also increases. While when our x decreases, our y also decreases. However, approaching our vertical asymptote, which is x is equal to 0. Then, the other one naman po, if our base is between 0 and 1, ganito naman po magiging itsura niyan. In this case naman, as our x increases, our y value decreases. And as our x decreases, our y increases, approaching our vertical asymptote, which is x is equal to 0. So, in general po, here are the following properties of logarithmic functions. So, first, for the domain, our domain daw po is the set of all positive numbers. While for our range, these are the set of all possible real numbers. And it is a one-to-one function for it satisfy the horizontal line test. And for our logarithmic function, we will have only an x-intercept, which is 1, wherein we don't have no y-intercept. And for this case, obviously, we have our vertical asymptote, which is the y-axis, x is equal to 0. And there is no horizontal asymptote.